Hello, everyone. How are we doing today? Are we good? It's good. I'm really happy to be here. Like, it's always good to be in Barcelona, right? When I tell people, so I travel a lot for work, and they ask me, where are you going next? I'm going to Barcelona. They're always like, interesting. So it has a lot to offer. And as a matter of fact, I'm particularly happy to be here, again at the AXA Auditori for DevOps Barcelona, because I have a long-standing history with them. Ricard told you. I spoke, because they organize many events, right? They're also the organizers of PHP Barcelona. So I spoke here in 2019, which was great. It was the first time I took my dad on the road, all that kind of stuff. And it even goes back way further. I remember the first time I came to Barcelona professionally was in 2011 at the PHP Barcelona event in Cornellà de Llobregat. So it goes back so long. So thank you for being here today. I usually say the joke, you have many options, many rooms. I don't have that now, so you're here. I'm going to try and make it work for you. And let me start off by introducing myself. Hi, my name is Thijs. Yes, that's how you pronounce that. It's not really a Spanish name, is it? I'm Belgian, by the way, Dutch native speaker, and I'm the technical evangelist at a company called Varnish Software. Now, by show of hands, who's heard of Varnish Software before? I am curious. Yeah, pretty decent, pretty decent. So I'm never under the assumption that everyone knows us, but when they do know us, they know us as the company behind a very popular Varnish Cache open source project. Who's heard of that open source caching project, Varnish Cache? Yeah, a bunch. Well, I'm not going to bore you with that too much, because this is not a Varnish talk, but yeah, we're a reverse caching proxy, both open source and enterprise, and we came out of that open source project as a way to support our user base, but also, as time went on, if you follow the timeline, to do enterprise products, and we ventured into the world of private content delivery and edge compute and all that stuff. The only metrics I want to share with you is about 10 million active websites use our technology, both open source and enterprise, and that reflects in, or that translates into 22% of the top 10,000 websites. So if you ask me what we do on a daily basis, is yes, we make... You're all right there? What we do is we make the web faster. Obviously, web acceleration, but we also enhance digital experiences by lowering end-user network latency, which is more our take on content delivery. So the pure definition of what I do is we build software-defined web acceleration and content delivery solutions with a strong emphasis on software-defined. We're not a CDN. CDNs have their role. We're grateful for them for keeping the internet afloat, but we do it based on software. You can host us anywhere you want. Remember, it's open source, there's an enterprise component, and the only thing I want to talk about before I continue as our claim to fame is the fact that we're currently the world's fastest content delivery solution. This is not a claim I make personally. This is not a claim we make as a company. Intel benchmarked us for their latest generation of CPUs called the Sapphire Rapids generation, and they had different tools they wanted to benchmark, and we came out with 1.3 terabits per second on a single machine. So that was pretty fast. And that announcement was made, again, everything comes to Barcelona, right, at Mobile Worldcon earlier this year here in Barcelona. Now, you may say, yeah, do I really need this? We work with a lot of telcos, a lot of broadcasters who do need that. The more interesting note is it translates into an efficiency number of 1.17 gigabits per second per watt. And I think efficiency is the name of the game, so if you care about less hardware, more efficiency, more density, less energy consumption, because electricity is expensive, and of course the sustainable aspect about it, that's our claim to fame. But again, I'm not here to talk about that. I just want to introduce you to the business I'm in. Now, if you want to follow me on social media, I'm at Thijs Feryn on all the platforms. Yes, I still use the bird. There's no X in there. I call it Twitter. You can send me a tweet if you want to reach out to me. You can also do it right here, right now. So if you want to banter me, you want to heckle me, maybe even praise me, I don't know, you can use Twitter. I will see the results afterwards. I'm the author of Getting Started with Varnish Cache, an O'Reilly book, an old one that I wrote years ago, but I also have a new one, which is Varnish 6 by Example. I mean, new, a couple of years was taken from us due to COVID, right? I wrote this one, a 778-pager, during the COVID lockdowns. I know the lockdowns were long, and while it's not related to the topic, I'm going to hand out a free copy, so if you're interested, walk up to me. I'm going to leave it here, so I'm not taking that back on the plane today. So the question you may ask yourself is, how does this relate to the topic at hand? Because remember, this is a K6 talk. Well, if you're in the web performance and content delivery business, and you claim to be fast, you need to back that up. So you need to be able to measure how much these systems can handle. And I'll tell you a quick story about something that happened to me last year that made this relevant to me. So I did a world tour, like a proper world tour last year. So my boss, our CEO, contacted me and said, Thijs, you remember that product demo you did about our private CDN solution? Would you like to take that around the world? I'm like, yeah, sure. So for the first time in my life, I bought a plane ticket, not from A to B, but around the world. Made stops all over the place, and did a demo where I presented a live CDN thing. And I wanted to show how fast it could be by introducing artificial traffic. So I was in need of a load testing tool. And I had discussions with colleagues what we were supposed to use. I mean, for our 1.3 terabits per second use case, we use WRK. But for this use case, K6 proved to be the perfect match. Now, K6 is an open source project. It is managed by the lovely people at Grafana Labs. And one of our solutions engineers showed it to me. And I was like, yeah, this could be something good. And I've done my world tour on it and many dozens of product demos using K6 to generate artificial traffic and give the system a run for its money. So in terms of capabilities, and there's not a lot of boring bullet point slides in there, but this is one of them, so bear with me, people. Stick with me on this one. K6 has certain capabilities. It is a CLI-based tool. We like CLIs, right? I like CLIs. It's very efficient. It comes with a scripting language in which you can define your scenarios. It's JavaScript. It has a rich ecosystem of modules in which you can enrich the language. Don't mistake it for being able to use NPM. It's not that kind of JavaScript. Remember, this tool is written in Go. It has means of checking what you're doing and presenting results under the form of checks, thresholds, and metrics. And we'll talk about that throughout the presentation. I'm intending to take up the full 45 minutes for this. You can also manipulate the testing scenarios. So you can put scenarios in place and choose how these get executed. That's something for all the way at the end. At the end of the presentation, I will take you through that aspect. And this is the second to last bullet point is beyond the scope of this presentation, but there is a test builder and a browser recorder that you can click and it outputs the JavaScript you need. And there's even full-on, like Selenium-style browser testing, headless, all that kind of jazz. What I am going to talk about is the last bullet point as well, is the fact that you can have tons of integrations in which you can store and visualize all your metrics. Now, the single most valuable thing I like about this project is that you can write your tests in JavaScript. Does that mean I like JavaScript? Does that mean I'm saying that JavaScript is the best language in the world? Hell no. Absolutely not. But it has its role, it has its value. And I like to use the comparison. The reason why I'm speaking English to you today is not because it's the most beautiful and best language in the world. It is the language that we speak. I don't speak Spanish, I don't speak Catalan, I wouldn't be able to help myself out here. And I think the same thing applies to JavaScript, right? It is, as we call, the lingua franca. A lot of people know it, so it's easy. It lowers the barrier of entry. And that's what I like about it. Not because it's a great language, it is accessible. Here's an example. Here's the most simple example of them all. You import an HTTP object from a namespace. You have an export default function. You do HTTP GET, endpoint, you run it, and it presents results. You're still on board? Not too complicated, the code? Still with me? All right. So now that you've developed the simplest of examples, how do you run it? Well, the way you can run it is threefold. You can run it locally using K6 command and then the subcommand run. And that's perfectly manageable using open source. The people at K6 also have an enterprise product, or a commercial product rather, where you can have all of that running in the cloud. So you can trigger it via command line. It would send all the requests to the cloud, and in the cloud they would orchestrate that and then take all the metrics in, visualize it, and it's nicely integrated. You can also do it via Kubernetes, also via open source. So this is how you run it locally using the open source tool. K6 run, you mentioned the script that you saw earlier, good to go. If you want to use the cloud, K6 Cloud, it takes that script, it sends the instructions to the cloud, and you'll find the rest there. Here's how you do it in Kubernetes. For the sake of doing it distributed, you have a cluster with this specific content type called test run. You give it a name, you give it parallelism. So in this case, 4 instances, 4 pods will be running it. You config map your script in it, kubectl apply, done. Pretty easy. However, important remark, while this is a presentation about distributed testing, I won't be using Kubernetes. I'll solely be using the K6 run scripts to do that. Now, before we can talk about distributed testing, I need to take you through the story. So let's start with you've seen the script, you've seen how to run it. Once it has run, you will need to see the output. And this is what it looks like. A K6 run gives you some metadata, some metrics. Allow me to zoom in a bit. This is what you receive. Is this a very representative test? Probably not, right? Like, if you look at the bottom line all the way at the bottom, we did a single iteration, and 2 lines up, you can see that we did a single HTTP request. Not really a good test, is it? But it goes to show that you can run a single iteration. You see all the metrics, average, minimum, the median, the max. If we go back to the previous slide, again, you see that it's much wider. You have percentiles and all that kind of stuff. So to make this a good test, we need to scale up the tests. And you can do this by specifying a set of runtime parameters. The first one is -u. U stands for users, so this is the number of virtual users that will run it in parallel with. In this case, 100 users, and the test will run for a full minute. And the iterations is variable. You'll see a number of iterations. If you want this to happen in a more portable way, then you put it in your script. You have this options data structure. You mention VUs, which are the users, the duration, and that's that. You can just run it, and you're good to go. Now, a remark about concepts like iterations, VUs, and the time. Who's heard of the cap theorem before? Is this sort of theorem where you say you can pick 2, and the third one is the variable? That very much applies here. So if you set the time and the number of virtual users, the iterations will be the variable. But you can do it the other way around and say, I want X amount of iterations and X amount of views, and the time it takes is the time it takes, and so on and so forth. So we'll be talking about that mostly near the end when we talk about executors and ways to define scenarios. You can choose which ones are constant and which ones are variable. But we need to dive a bit deeper into the HTTP aspect, because this is purely about HTTP. My world, the world I work in, is purely about HTTP. So you've seen this one. Straightforward, single iteration, unless you provide the command line arguments. You can actually run multiple HTTP calls within a single iteration. Mind the backticks. These are not single quotes, they're backticks. By using that, you can use that interpolation syntax that you can see here. You can inject these IDs. Now, what you've probably noticed, I'm using test K6.io. It's this playground that the people of K6 generously provide. So you can use it for all kinds of things. And you can see throughout all my code examples that I'm always using stuff like that. So it's perfectly replicable. I'll publish these slides online afterwards, and you will be able to use that. Now, HTTP request is much more than just calling an endpoint. You can inject certain parameters like cookies or headers or all kinds of stuff. Of course, you'll do that to mimic the behavior that you want to achieve. In terms of parameters that you can inject, you've seen the cookies and the headers. You can also maintain state through a cookie jar, meaning that when you do a request and it does a set cookie, it will store the value, present it upon the next one, and maintain the state within the stateless protocol that HTTP is. You can do headers, you can do authentication, you can read the list, right? Redirects, tags, timeouts, compression, you name it, it is all there. Of course, things go beyond regular GET requests. Maybe you want to do test a form submission like this one. It's an HTTP post. You use that typical key equals value ampersand syntax, like regular form submissions do, or you can turn it into JSON, right? Turn that string into a native JSON notation, but then use JSON.stringify to turn it back into a string and set the content type. This is how you test APIs. Still with me? Still straightforward, right? The API is also straightforward. There is a method for each of the request methods that you can use. And there's even a more abstract request one, where you can specify the request method on the fly. There's even ways of batching it. And batching it means having multiple HTTP requests together, and then multiple TCP connections will be opened, and it'll be sent in parallel. Here's an example of how you would do that. There's multiple syntaxes. You saw when I go back, it's either an array or an object that you can send. Well, I chose array with the request method, the endpoint, and then it'll just run it in parallel. And then you can check how it responded. So what I'm doing here is I'm checking the first response and seeing if the response status was 200. And that's where we introduce a new concept, the concept of checks. What do checks do? Well, straightforward, they check certain assertions. You can check, for example, as you can see, whether the response status is 200. And you can inject whatever value you're trying to assert using, in this case, I'm using res, which is the HTTP response, and we give it a name. In this case, its response code was 200. But you can have multiple ones if you want. So this is the API, the value that you want to set, then the sets you want to check, and then you can tag these things. Now, here's where we need to pay a little bit of attention. When the assertion fails, the execution does not stop. Keep that in mind. What it does instead is it keeps a metric of the successes and the failures. And that's what makes it interesting. So you can use this, and then you can tie in another one maybe, check if HTTP2 is used. And when you use the single one and you run the test and the check succeeds, then, and again, I'm going to zoom in for your convenience, you can see a green check mark, response code was 200. And then you see the checks metric all the way at the top that says 100% has succeeded. Of course, when we fail, and that can occur, for example, the status code was not 200, so when we look a bit closer, well, it didn't succeed, and the checks is at 0% because one failed. So that's a check. Use it to see how successful your tests are. You can do a set of assertions, and those will be met. If you do want to stop the execution when criteria aren't met, you need to use thresholds, which is another structure within that JavaScript language. Here's how you do that. You define, again, in that infamous options data structure, you can define a threshold. The thresholds are the official metrics. Could be failures, durations. You've seen them all in the list, right? And then you provide one or more thresholds that it needs to meet. So in this case, the failure rate needs to be below 1%. And the request duration, at least the 95th percentile, needs to be below 200 milliseconds. If any of these thresholds are surpassed, then execution stops. Here's how that works. Again, the screen is a lot bigger than I expected, so I don't think I need to zoom in, but still my next slide is a zoomed-in version of this, where you can see the two green check marks because the criteria were met. Now, of course, we'll do a little bit of chaos engineering here and lower the threshold to such a level that we'll never meet in this test, and then things are bad. Then all of a sudden, at the bottom, all the way at the bottom, you see the error thresholds on metrics, in this case, HTTP request duration, has been crossed. The execution stops and halts to a grinding halt. And you see which one failed. Now, of course, if we slide the screen through, you'll see why that was the case. The 95th percentile was at 100, where the limit was 90. So that's a way of stopping the test. So keep in mind, checks, thresholds. You can define multiple ones if you want to for a single metric, and you can have multiple metrics. So you have the flexibility of setting this up the way you want. All right, let's go to the next topic, which is tags. You can tag content. You can use that to identify certain tests, or if you want to maybe segment your tests. And that applies to checks, thresholds, metrics, requests, the full thing. There are system tags that you can use, even in thresholds, to set a threshold only if the protocol is HTTP2, or only if the status equals 200, all that kind of stuff. The reason why I like using tags is because you can inject your own tags from the outside world, maybe even. So you could say, again, this relates to my use case. I build a multi-CDN using nothing more than software with nodes in the EU, the US, and APAC region. So I wanted to know ahead of time where the tests came from. So I used a tag. So I said, this test is coming from the EU. If you want to globalize that and make sure it applies to all the tests, you can, again, use that infamous options data structure mentioned there. But that, again, that makes it, this code is not really portable, because the code itself only applies to the EU. If you want to do that at runtime, then you can specify tags at the top level, which I use for my tests. But then, unfortunately, you can't use the syntax you saw earlier. You need to use something called exec.vu.tags, and then the tag we get is location. I've introduced something new, a setup function, which you see in a lot of testing, right? Set up and tear down. It sets it up, it checks, or it assigns a default location, in my case EU, and then based on the value that was injected on the command line, we pick the next one. You can return from that setup function, and that then becomes a sort of a dependency injection in our main function where you can access that data. And in this case, I'm actually calling a dynamic endpoint based on what was injected at the command line level. But if you want to use tags in your thresholds, you can say, look, the request duration in general at the 95th percentile should be below 500 milliseconds. That applies maybe to tests done in the APAC region. However, we're making exceptions for EU and US and setting different thresholds that need to be met. So those tags are quite useful, not only to segment the execution, but also for meeting certain expectations. Maybe you have beefier servers in the US than you have in the APAC region. Let's carry on with groups. Groups are very similar to tags. Groups also try to segment and categorize certain aspects of the execution flow, but they're much more explicit. You can define a group, and in that group, in this case, the group is called get. So all my HTTP GET requests are grouped there. As you can see, it has 2 checks. And in the next slide, you'll see that we also have a group for post calls, which also has the checks. And then in the end, and that's the fun bit of it, the group name is added as a tag. So everything below that is tagged appropriately. And I think the proof is in the pudding. If you look at the output, you can see, again, let's zoom in, that there is a get group with the checks that were met there, and a post group with the checks that were met there. So from that perspective, it's quite easy to see how it was executed, and it gives you a better hierarchy of the tests. Now, I mentioned the setup function that we needed. This fits into the next topic, the topic of the testing lifecycle. Now that we have these basic knowledge of the situation, we can inspect the lifecycle of a test run and try to optimize there. So let's start off with just the API of how things get run. In this case, the comments matter. The green comments do matter. So everything that is outside of a function scope is init code. And init code is run once per VU. Again, as a reminder, a VU stands for a virtual user. If we have 100 virtual users, this is going to be called 100 times. Then we have the setup code, which you've seen earlier. And as you'd expect, that's only run once. It's to bootstrap all the preconditions. That gets called once. You've seen the default function. That runs once per iteration. And an iteration depends on a virtual users. So if you have 10 virtual users and 10 iterations per virtual user, this function is going to be called 100 times. And then, as you'd expect, of course, when you set things up, you tear things down, the tear down function is also called once. Now, you want to see some code that makes sense, I guess, right? Well, I have something in store for you. I had to be very creative. Not so creative, depends on how you interpret this. Again, I used endpoints generously provided by the people at K6. So, of course, we import the HTTP namespace. We need that. And then in the setup function, we're going to get some data from an endpoint provided by the people at K6. And it's a JSON structure. We analyze it from the result. We pick the JSON function, which JSONifies this into the native JavaScript notation, get a property called slideshow, get a property called slides, return it, and then we call it in the execution function. And then you just loop through it. And when we tear down, it's a bit difficult for what do you need to do in HTTP when tear down happens? Is there a lot of cleanup to be done? No, there isn't. So I resorted to just doing a console log. Does that make sense to you, lovely people of Barcelona and other places? Are we still on board? Let's take it to the next level. Let's access some metrics. You've seen the metrics, request duration, waiting time, TLS time, all that kind of stuff. You can access them directly in your test, either for logging or if you want to make some decisions that are based on that value, you can actually access from the result a timings property that has a set of timings. In this case, it's duration. But you have many more. Blocked, connecting, handshake, sending, waiting, receiving, duration. You know these from the end of test summary that you've seen. You know the ones I zoom in every time, those are those metrics. But of course, you can define custom metrics, and that's where the fun really starts. Maybe you have certain assertions that aren't, or certain metrics, things you want to measure that aren't really met by whatever K6 is offering you out the box. So here again is another example of mine. Now I know if code is on a screen, people will read it. So I need to respect that, because I know now your attention towards me is reduced to 50%. I know this, but it's fine. It's absolutely fine. So we start by importing the things we need. And for the first time, you see an external import, a piece of JavaScript that lives remotely that is pulled in. And we're specifically getting a function called random item, which allows us to randomize the tests we're doing. So this is more or less a fake test, right? If you look at that statuses array, it's either 2, 3, 4, or 500. Throughout the test, we're going to randomize status codes using that endpoint provided by people of K6, where if you pass a status, it will return that status. That's how that goes. But what I'm trying to show you is that you can define your own counters. We're going to count the number of 200s, 300s, 400s, and 500s. So whenever that test is executed, and based on the randomness, some status code comes out, and when it's between 200 and 300, we increase the 200 counter. Between 300 and 400, the 300 count. You get the point, right? So in the end, and this is where it gets cool, you have extra metrics all the way there. Rest 200, 300, 400, 500. So if you want to measure something completely custom, you have the instruments to do it. And mind you, I only showed you the counter. So if you go back to the code, you see rest 200.add, and you add a value. That's a counter. And what we know from counters, and that's useful to know, is every time you add something, it accumulates. A counter only increases, cannot decrease. If you want to present the last value of something that can go up and go down, you need a gauge. You can define that. It always presents you the last value, and it knows the min and the max value. If you want to keep track of rates, you have a rate counter, custom rate counter. What rate does is, whatever you pass through it that evaluates to 0 or false is not included. Whatever is returns to true or a string or whatever value of that kind increases the rate. And then finally, you can define trends as well if you want the percentile, the averages, min, max. You know how that works. So that's how you can control either access your own counters or define your own counters. And that, of course, all fits in this end of test metrics, because that's what you've seen so far. But we'll take you on a ride that goes way beyond that. You know this one. You've seen it. I've presented to you multiple times. It's the standard format. You can alter the format if you want to in your code, again, using options, to say, I only care about average, min, max, count. Don't put the percentiles in there. And what happens then is that things start narrowing down. It comes a bit more dense. If you want to do that in a more portable way and change it ad hoc, the command line is there for you. But ladies and gentlemen, there are situations where you don't want an end-of-test summary. And that's where we're going to go in the next couple of minutes. And before I do that, I want to mention that you can also output JSON if you want to. And you can output it to a file by putting an equal sign next to it and the file, and it stores it there. Same for CSV if you want to interpret that. But that's just end of test. What happens during the test? If you have a long-running test, maybe you want some real-time metrics. And this is where we're laying the foundation to go from like standalone individual tests, like you know from tools like Apache Bench or Siege or maybe others you use, to something that is a bit broader. So you need to centralize the storage of your metrics in real time so that you can access it. If you have multiple nodes doing the tests, you need a centralized place. And luckily, people at K6 provide a bunch of integrations. A bunch. Really cool. What I'm going to use today is something I know. I'm not really good at it, but I know it. It's Prometheus. Who uses Prometheus here? See? Yeah, it's a decent number. Now, I would like to warn you, if you use the native K6 Prometheus integration, it didn't really work well for me, because their approach to it is sending metrics in real time to that endpoint, the Prometheus server endpoint. Meaning that if you do tests at very large scale, your Prometheus server needs to scale along, but it'll be getting a ton of requests. And I didn't like that approach. I wanted to do it the other way around by saying, look, I want my K6 instances to be scraped by Prometheus at the pace that Prometheus can handle it. And you need a custom module for that. And that's where we're going to dive into XK6. XK6 is a program that allows you to build custom K6 binaries with custom modules. In this case, I'm using a community-driven Prometheus endpoint or Prometheus plugin by, how do you pronounce that? Skiba, maybe? Well, whatever the name of that person is, the module that he or she built is pretty good. So when you do XK6 build with and then that endpoint, that Skiba XK6 Prometheus at latest, it produces a brand new K6 binary. This is all Go stuff. And then you can run that binary and say output equals Prometheus, and the namespace is whatever namespace for Prometheus you want to use. I use K6. And the port you want to use is 1990. And what happens then is, as long as your K6 test is running, on port 9090, there is an endpoint you can scrape. So if you want to do a curl on that port 9090, that works. And this is what comes out, Prometheus output from those tests in real time as the tests run. It's pretty cool. So what tool, ladies and gentlemen, would we then use to visualize? What would we use? What comes to mind? We use Prometheus. How are we going to visualize this? Yes, I hear some interesting words in the background, maybe a bit louder. Of course, Grafana. They develop K6, of course. So that's where we start our journey from standalone into more distributed tests. So you can do multiple instances of K6. You can put them on many boxes spread across the world, and as long as they're scrapable using that -O on that port, I choose port 9090, then you can alter your Prometheus configuration, mention those, and this reflects the tests I did, but I anonymized it. You don't get the real endpoint, you get Dublin, California, and Singapore. And then I add that location label for the sake of producing these kinds of statistics, which are kind of useful. Then the end result is this. And this is what I like. So when we're doing testing, and this is not really high scale, I mean, from Ireland, we're sending 1.89 gigs a second. I think on regular stock Amazon boxes, I think I went all the way up to 25 gigs a second on a single machine. But if you, just a word of warning, if you want to reproduce that setup with 3 of those servers and a bunch of EdNodes, I think that cost me €1,000 a day to run that. So be careful, don't go too crazy. But what we did here is did tests from multiple regions, and in real time you can look at Grafana and see how the client is behaving. These are not server statistics. These are virtual users. So it's a developer's dream, right? Having insight in what the end user is seeing. This is not the actual end user, but the scenarios we developed should mimic that behavior. And then you can see what the time to first byte is, you can see what the total request duration is, what the throughput is, and these were really the metrics I cared about. I wanted to prove that our software could do sub-millisecond latency, which is proven in Ireland and the US, not so much in Singapore. Something was happening with my Singapore nodes. You see that during my tests. Of course, how do you do that? Some of it is just native Prometheus metrics. Some things require a bit more Grafana magic. Like if we want to know the number of requests per second per country, then you need to use a rate function in Grafana, add sum to it, then use by country. You'll figure that out. I'll share those slides if you want to use that. If you want to know the failure rate, again, you need to use a rate function. Some came natural, and then at the end, if I wanted to show you the throughput in BPS or megabits per second or gigabits per second, again, a rate function, and then multiplied by 8 because we want to go from bytes to bits. That's it. And that's how we visualize distributed tests. But in order to actually control distributed tests, you need to do a little bit more. And that's where K6 provides API access. So out of the box, and I'm doing it explicitly, -A 6565, even if you don't provide that 6565, K6 will already have API access over HTTP on that port. So what I'm doing here is I'm preparing myself for a long-running test, maybe a test that lasts 2 hours. And that pauses in the middle because I decide to. And maybe I want to scale up, and maybe I want to scale down. That's why I put everything in motion, the script that we want to execute, the endpoint that we want to control it over port 6565, Prometheus output on port 9090, and very important, we're starting in paused state. It's like having race horses at the track ready. They're behind the gates. The gates are still closed. And as soon as we resume, we open up the gates and we unleash the horses. But in order to do that, you need to alter your script a bit. And that's where we venture into the world of scenarios and executors, which is the topic that I'll talk about within 11 minutes, because that's the amount of time I have. So you need to define an externally controlled executor, where we will set some boundaries. You can't go nuts, right? We start with 2 virtual users, and you cannot surpass 5,000. And the tests will run for 2 hours. And when you do that, and here's the magic, on my local laptop, I could control a node that is in Ireland. Sitting in Belgium, I can say, OK, let's resume the test in Ireland. So that endpoint 6565. Oh, we only have 0 virtual users. Don't worry. We can do K6 scale of that endpoint. And boom, it starts firing up. The horses have been unleashed. And I'll do the same thing in the United States. I'll do the same thing in Singapore. And that way, using that command line, you can control the execution. You can resume, you can pause, and you can scale remotely, which is very convenient. If you don't want to do that using the CLI, remember, CLIs are nothing more than wrappers around an API, you can use the built-in API for that, which is kind of useful. So you can say, on that 6565, call it via HTTP, and then v1 status, and it gives you all the status information you need. So you can write your own software or integrate that in whatever pipeline you have. If you want to scale it up, you do a patch call. Again, this is a REST API. You provide the data structure, you say vuse is 500, and you get the confirmation. And despite having Prometheus as the store to store all the metrics, if you still want, you can access metrics directly. And that's kind of fun. So that is the main bit about distributed testing. And I would say go nuts on it. It's an open source tool. It's very nice. If you don't want to go to the hassle, here's where I give K6 some credits. They also have a commercial product. I'm in no way affiliated with them. I'm in the web acceleration and content delivery business. I just happened to discover this. So let's use the 9 remaining minutes to talk about scenarios. So another thing I have to mention, I have been ill. I've caught a cold last week, and I went into an intensive program using legal drugs and water and hot beverages, and I managed to suppress my cough until this point. So I asked if they had a mute button, so if mid-sentence I have to burst into a cough, I could mute it, but I think I held up pretty well. So apologies for the interruption. So scenarios are quite cool. Scenarios allow you to define in your code, and you've seen that so far, the number of virtual users, the number of iterations you want to set, duration. But there's also other aspects, such as when do the tests need to start? Immediately or after a while? And what executor do you want to take? And again, we go back to the beginning of the presentation. The 3 type of things you can do. You can either choose 2, and the third one is the variable. And here's an example of a combined example where we use shared iterations or per VU iterations. So in this first case, we're having shared iterations, so that means 100 iterations are ready for the take, and there's 10 virtual users picking off work from the list. On the per VU iterations front, every VU gets 10. So it's the same amount of work, but they get executed differently. In this case, shared iterations start, and after 10 seconds, per VU iterations kick in. Just an example. What I really want to get to is the fact that you have many execution flows, where you do shared and per VU iterations, where you set the VU, and the iterations are then the consequence of time. You can set the VUs to a constant level. You can do ramp-ups of scenarios. You can also use arrival rates, which is more about setting your expectation on the iteration rate per second. But don't worry, I'll walk through most of them. So here's the standard one. You've seen it, shared iterations. There's 200 iterations. There's 10 VUs. That means, on average, not absolutely, each VU will take 20. But it depends. If one is faster than the other, it could take off work from the list. And we set the VU to an absolute value, and we set the iterations to an absolute value, meaning the time is variable. However, we do set a timeout. If it takes longer than 30 seconds, stop the execution. Now, I got this scenario from the K6 website, and they have this nice graph illustrating this. Now, the colors are a bit funny here, so I'm going to have to step off the stage for a second to see if I see. No, you're not exactly seeing that. There is a gray behind the blue, apparently. This is where I messed up, apparently. I can see it on my screen here, but you can't see it there. You can see the number of VUs. So you don't see a gray background, right? None. I'm sorry about that. Well, imagine there being a gray background. Imagine, just imagine. Use your imagination, Barcelona. In this case, that ramps up to 10. So what the point is, when you use shared iterations, it takes 8 seconds. So everyone picks off work. However, if you do per VU iterations, and that's the point I'm trying to make, it could be less efficient. Could be. Because of idling VUs. If everyone has the same amount of work, and one does it faster than the other one waits. Like, I have nothing to do. If you share him, he could pick off other work to meet it faster. It depends on how you want to do that. If you want to have constant VUs, then the other things are variable, right? So we set the VUs to 10 always, and the duration set to 30 seconds. What is variable? The iterations, of course. They go up, they dip a bit, they're not constant. Again, you can have scenarios in which you can do that in a more elaborate way. What I'm doing here is ramping up. So we're starting with 0 virtual users. We're going to ramp up for 20 seconds to 10, and then we're going to ramp down for 10 seconds back to 0. And in total, it will last 30 seconds. 20 seconds to build up, 10 to go down. And you can see how that works. That takes 30 seconds as expected, 20 up, 10 down, and the virtual users act accordingly. But what is really cool is if you don't care about that, but your primary metric, the thing you want to measure, is the iterations per second you want to hit, then you can use arrival rate. So in this case, the virtual users are variable. We're setting a timing duration, a test duration of 30 seconds. So we fixed that. The other thing we will fix is that we want 30 tests or 30 iterations over the time span of a second, so 30 a second. And then the VUs start at 2, and could go to 50 and will go in between. So that's the variable. And you can see that this line is flat out at 30 iterations a second, and the rest will adjust itself a bit. And as a final slide, this is the very last slide I have for you before, 4 minutes left before we send you packing, is externally controlled. You've seen that. I think if you want to do distributed testing and you want to use the API that I presented to you, this is the one you want to use. If you want to venture out and do other tests, be my guest. But this is the one you need to use to do actual distributed testing. So this is the end of the presentation. I hope you've learned something new. If you didn't, I hope you enjoyed me being here. Thank you, Barcelona. It's always been a pleasure. We go back a long way with this city, and I hope I can come back someday. Thank you very much. Now, before Ricard kicks in, I make a sport out of it, of ditching Q&A. And the reason why I don't do Q&A usually
okay.
is we'll do Q&A. Don't worry. Don't worry. It's because a lot of people are too shy to ask questions, but maybe in a virtual format that's not the case. And a lot of questions that are asked are hyper-focused on that specific use case and are sometimes irrelevant to the crowd. So I make a sport out of it of using all my time. But now we have 3 minutes left, so Ricard, you probably...
No, I mean, some of the questions, you were answering them through the presentation, which is absolutely fine.
That's great.
There's one that, there's probably no good answer for that, but yeah, I mean, they're asking, like, if you have any suggestions to actually mimic some real production behavior instead of, like, hammering mostly, let's say.
Well,
yeah.
I'm gonna give you my perspective on it, how I approached it. I wanted to hammer this system. Because I didn't want to show the real production scenarios. I wanted to show how much our software could handle. Because that tour was a commercial tour. I wanted to show, look, these are metrics we're doing, and I'm not faking it. It's happening. So if you want to really mimic the real deal, I would try to figure out scenarios that are quite common. You have the language to do that. You can mimic certain behaviors. And what I would do, which is maybe a separate talk, is I mentioned all the way in the beginning that you can do browser testing as well. And really mimic those scenarios. You have a browser recorder, you can define scenarios. I would do that. And I would do different kinds of testing, because if you go to the k6.io website, they have the different things they do. They do smoke testing and like all other kind of stuff. Look at how they explain it. They're far more specialized than I am. I just happened to stumble upon the tool, needing it to do the work I needed to do. So I didn't really answer that question, did I?
No, but I think there's no actual real, like, silver bullet.
I've seen that question being asked a lot of times, and I've seen...
Well, it's good to have insights anyway, how you would approach this.
I didn't do real tests. I just wanted to slam the system. That was my goal. And it kept up wonderfully. That I need to mention, in favor of K6. Again, I have no affiliation with them, but it was really fast. I could send 25 gigs a second without that system choking up.
Well, that's probably more than enough as a test for most.
And they have recommendations on how to tune your kernel for it to keep up with that.
Okay, so okay, good to know. Yeah, they're asking, like, and I checked that there are apparently some pull requests open, but how do you do, like, fuzzing in terms of testing, or is it always more or less the same request, right? I mean, in terms of, like, the actual content of the request.
Well, so you want to test different aspects of
I guess they are asking about different payloads, maybe, or different kind of thing, for fuzzing the data that's sent to the system.
Different kinds of tests. You like maybe do a video playback versus an image versus...
I'm assuming they're asking about payloads that are different to test the system React.
You can do whatever you want. I mean, you have the full scope of the JavaScript language at your disposal. Just to show what I did with it was pretty left of center. I used it to do HLS video testing.
Oh, wow. Okay.
So that was my goal, because that's where, for us, challenges are. So I actually faked the video player and did fake adaptive bitrate filtering in JavaScript. Really poor man's adaptive bitrate filtering. So the payload was very varied. I accessed digital files and 4K video streaming files.
No, maybe they're asking about if there's something integrated that does automatic fuzzing instead of you writing some code. But again, I'm guessing because I only get the question.
We can only reply to what we can read.
And
right?
a very final one, very quickly, 9 seconds. Someone is asking, and I'm curious about that. What's your thoughts on, okay, this kind of tools kind of help doing DDoS attacks?
Oh, yeah.
As well.
Oh, yeah.
So what can we do?
Well, that's when you
Maybe
get...
nothing, no?
No, yes, there is. And that's where you get into our business and the business of some of the sponsors here is security services, content delivery, acceleration. That's where we can help you.
Okay.
So instead of We introduce new problems that we can solve.
Okay, fair enough. All right, thank you, Thijs.
Thank you. Thank you again. Thanks, Ricard, for inviting me.
Yeah.